Today I did the problem of unique Length-3 palindromic. I don't even know if that's how you pronounce it, but palindromic subsequences. So, okay, and here is an example. So basically, what they want me to do is that we're gonna search through the string that's given, and then we're gonna check if there's a 3-letter palindrome. So right here, ABA. So A, B, and then A, and A, and then ACA, and then it's also saying that once you've checked the let's say you checked for the palindrome, let's say B, right? Once you check all this, when you move it to A, you're not going back in order. So like once you move forward, you can't, everything over here does not count. Okay, so my idea for this problem is that since it's a 3-letter palindrome, the first and third, or like first and last letters, will always be the same letters. So let's say, for example, we want to find the number of palindromes. I'm just gonna go ahead and check for the first letter, and then I'm gonna keep moving, or not really keep moving, but like I'm gonna go straight to the last to check if there's a letter that's this, or character, to check if there's a character that's the same as the first character. So boom, we have that. So now all we have to do is just check, or just like put this into a set. A set is basically a array that's like always unique. So every element in that array is unique. So it's gonna erase this, and then we have C, B, and A. So then C, B, and A, that's gonna be the count of our palindromes. So that's 3 already. And then now, since we've already counted for the B, all we're gonna do is that we're gonna search. So once we found out the palindromes for B, we're gonna move on. So let's say B, boom. What we're gonna do is we're gonna check if B is already in, if we already seen B. So we already seen B, we're gonna skip that, and now we're on C. So we're gonna move to the very bottom of the list, and then check if there's a C. If there's no C, we just continue. And since there's no C, boom, we continue. If there's B already, there's A. Alright, let's check A. We're going to the last letter. Oh, looks like it's over there already. So now we're gonna look what's inside the range of those A, which is just B. So then it's gonna be 3 plus 1. That's gonna be 4, and that is the answer. So first, I'm gonna set the palindrome. Of course, we're gonna have the integer palindrome just to count it, and then we're gonna have the set, which is gonna be this unique. Is just gonna check for. It's just a set that checks if we've already seen these first few letters. So let's go through the code one by one. So for I in range S minus 1, so that's gonna iterate through this entire list. If Si is not in unique, so let's say the first item is gonna be B, in unique right now is set to nothing, so it isn't in unique, so we can move forward and go to the next for loop. So for J in range length S minus 1, I minus 1, this is basically saying that J is gonna iterate through the back of the array, so it's gonna go backwards instead of iterate through like boom boom 1 2 3 4 5. It's gonna go to like 5 4 3 2 1. So in the range at the end, it's gonna be the I, because we don't want, let's say A's we're at A, we don't want the J to be all the way over here, because we're not tracking the characters before A. So it's gonna track all the way from the back to our current one. So what it's gonna do is gonna check if S is equal to Si. So basically, what this is saying is that it's gonna check for the letters if it's equal, because we know for the palindrome, the first and last letter has to be equal. So it's gonna check A. Boom, no, it is not equal. So it's gonna check B. Oh, now it's equal. So what do we do when it's equal? So all we have to do, since this is Python, we can just add a palindrome. We're gonna add the length of this, which is just the range of S I plus 1 and to j. So what this is gonna count all the characters from I plus 1, which is over here, and then j, which is over here. It's not over here because in Python, or like in general, it's exclusive. So like the last letter, we don't count. We don't count the last letter. So it's gonna be B to A, and then it's a set because we don't care. We don't want any unique letters because we already counted the palindrome. So it's just gonna be CBA. So that's 3. Boom, we have 3 already. So palindrome is at 3. Palindrome is at 3. And once we know it's at 3, we can just break out of this loop because we can just break out of this loop because we found all the palindromes for V. And then it's gonna add the character to the unique list. And then now we just repeat it again. So if S is not unique, so we already found out that B was not in that list, so we can just skip this B and then go to C, and J is gonna loop over here, and it's gonna be like, oh, there is no C, so we can just skip through that and then go to the next letter, which is B. We already found that. So next one is gonna be A. So J is gonna go to the last letter, boom, B, and then what's gonna do? It's gonna check if it's equal, boom, of course it's equal. And then for the palindrome, it's gonna check over here, which is only 1. So we do 1 plus 3, and that's 4. So for this algorithm, it is not that effective considering the range of the possible like length of the character is like a crap ton. So my thing is not very good, So